Hello everyone, welcome to my program Question the Answer. As we know that the world is full of ready-made answers. People go to Google and find out something, and Google has not only that answer ready, but Google also gives you answer of many other questions possible. Having the technology, having that information is not bad. But the trouble is sometimes we are caught up with too much of information and the curiosity is lost. And if you're not curious, if you do not ask the question, what is the point of being a student? What do you want to learn? What are you going to learn anyway? So this entire series is based on asking questions and the questions leading to us a journey where the answers are explored. This is what we call as investigative research in the field of science. Today's topic is continuation of the previous topic. In the last segment, we studied about how J.J. Thomson had discovered electron and he had put forth his model about an atom. We also discussed about how was discovery of electron responsible or in a way a factor towards understanding that atoms exist. This is not direct, but Thomson thought about something and he realized that the atom must be existing and the negative electron must be a part of the atom, inside the atom. This entire thing led to his first atomic model. His first in the sense that the first atomic model that he put forth. And that atomic model looks like something like this. This is the atom and the electron, negatively charged electrons are suspended here. Like the plum would be suspended in pudding. Now what happens is, this is an atom and according to Thomson, this atom is fully positively charged object. Inside this positively charged object or inside this positively charged sphere, the negatively charged electrons are embedded. Now if that happens, that means the total atom electrically neutral, which it should be, and the atom becomes the basic building block of the entire element, which is what is expected as well. However, this model had certain problems, and that problem was the first and the biggest problem is that the negative charge electrons and positive charge were touching each other. Now how can the positive and negative charge be touching each other? Because if you know that if the positive charge and negative charge are brought close to each other, you will see some spark and the charges neutralize each other. This spark is because of the jumping of electrons from negative to positive. When the distance is very small, the electrons will jump. And with that a lot of energy is released and because of that energy a spark is seen. That is the idea behind welding. It's about this jumping of electrons when the extreme negative charge is brought to positive charge. The jumping of electron will release a lot of energy and because of the energy, only a certain part of the metal will melt. That molten metal immediately, once you stop the welding, the molten part of the metal will immediately solidify. And so as a result of that, the discontinuous parts of the metal appear to have joined. They are joined like that. This entire process is based on the heating effect and the heat is provided because of the sparking. This entire thing is also, this is based on that entire example of sparking or the example of sparking of a thunderstorm, lightning. When the lightning strikes, it is basically the entire clouds have become negatively charged. And because of the extreme negative charge that the clouds have gathered because of the friction, the equivalent positive charge is created on the floor, on the ground. How do we create that? By induction. The negative charges will repel the electrons. So the entire Earth's surface, the electrons are pushed on the other side as low as possible, which makes the entire surface of the Earth devoid of electrons and a positive charge is developed. and these electrons from the cloud will jump towards the positive charge, and this jump is producing the spark which we call as lightning. This entire thing is based on the positive and negative being separated. If they are together and if they are touching each other, they will not remain negative and positive, they will become electrically neutral. The fire and water can exist together. But if you pour water into fire, how can they exist together? Water will not remain water, fire will not remain fire. The entire thing will completely, if the fire is too much, then the water will evaporate. And when the water is adequate in quantity, the fire will be put off. Similarly, if the negative charges and positive charges are brought next to each other, they will balance each other out. If this happens inside the atom, J.J. Thomson's atom is showing, the model is showing that the negative and positive charges are touching each other. If they are touching each other, how can they exist? They will balance out each other. And the atom will become not only electrically neutral, but will be completely devoid of charges if there are no charges inside the atom. You think it like that. If the atom is not having any charges, because the positive and negative charges balanced each other, so there is no charge left inside the atom. I am not talking about net charge. There is no electron left because electron has balanced out because of some other positive charge. So if there is no electron left inside the atom, there will be no electron available for us ever, because atom के अंदर ही नहीं है. Atom से electron आके तो charge बनता है, current बनता है. If there is no electron inside the atom, the current can never be found. So all of this, Thomson had understood that there is a big contradiction here. But he could not find out what is the contradiction. For him it is very easy to say that there is a positive charge here and there is some negative charge here. This is positive, this is negative. But the trouble is, if the positive and negative are inside the atom, so close to each other, then the attraction will bring them closer. And if the attraction brings them closer, they will touch each other. And if they touch each other, they will balance out each other. So basically Thomson did not understand how is this possible that the two charges must also exist. They will not balance out each other. But they are so close in such a small space called atom. But they cannot touch each other. How is that possible? The attraction will be so large. If the distance is reduced, attraction increases. The distance is so small, attraction will be so large. Honestly speaking, Thomson could not go beyond this point. Thomson was working as a professor in a university, and in the same university there was a student. The name of the student was Rutherford. Now Rutherford was an old student in that university. Rutherford graduated, he did his masters as well, and then Rutherford joined as a fellow teacher, fellow professor in the same university. So Thomson was his teacher, his professor, but now Rutherford and Thomson were colleagues. And Thomson knew that Rutherford was a special one, a genius one. As a result of that, when this entire fiasco about the atomic model happened, when the Thomson had discovered something so amazing about an electron, that Thomson got Nobel Prize for it. But the model of an atom that Thomson put forth was really shabby. So the question was how to improve this. The electron's discovery is right, but the atomic model is completely rubbish. How can handle this? Thomson called Rutherford. Thomson was getting old as well, possibly. So he called Rutherford and he said, maybe my time is up, maybe my bit is done. I think it is up to you now. You take the honors. He handed over some important papers to Rutherford. Rutherford said, alright, I'll take charge now. I'll look into this. And Rutherford started to drive back home. Before we discuss anything about what Rutherford's work was and what Rutherford did about the atomic model, I think it is important that we know that the famous experiment of finding out there is a box here with a small aperture. I'll draw it properly. Such a box was prepared and kept, and inside this box here a radioactive substance was kept. Now what will happen is, through this gap a radioactive ray can come. There is a positive plate here. No, there is a negative plate here, let's say, and there is a positive plate here. It can be exchanged as well, but ठीक है. And there is a photographic plate here. Initially, right at the center, there was a spot at the photographic plate, which indicates that the radioactive, whatever were the radioactive radiations, they were directly incident at the center. But once we started, this positive and negative plate were applied and the current was switched on, or the voltage was applied, the central spot was there, but one more spot was observed, and that was here. Oh, I made a mistake. Yeah, it is here, but much away towards the positive side, and one spot is towards the negative side, but it is deflected much lesser. The deflection is much lesser. It is obvious that the particle which is coming on this side and it is deflected towards the negative side. It is deflected away from the negative side. That means this must be positive. Because it is positive, which is attracted towards the negative side, it is repelled by the positive charge. Similarly, this must be negative because it is attracted towards the positive charge. This negative is called as beta particle, this positive is called as alpha particle. And the one that went straight on is called as gamma radiations. They are not particles, they are radiation. This experiment was conducted by a gentleman whose name was Ernest Rutherford. So Rutherford had already done something that was amazing. He had discovered basic three types of radioactive radiations. The radiations out of radioactivity, he had discovered that one is a particle, which is alpha particle, positive in nature. The second is a beta particle, negative in nature. And the third is gamma, but it's not a particle, it's only a ray, it's only a radiation, it's only energy being radiated. The positive particle is heavy. How do you know that? Because the deflection is less. We know the loaded truck cannot rotate easily. A cycle which is, if there are more than one people sitting on a bicycle, it is difficult to turn the cycle. If a man with who has a lot of weight is running, it is difficult to change the direction. Light objects, the objects whose mass is less, you can easily change the direction. The change of direction happened more, so it's obvious the beta particle must be lighter particle. The change of direction here was less. So clearly alpha particle was the heavier particle. This was a genius experiment. And ever since Rutherford performed this experiment, he had gathered a lot of attention and a lot of people were looking up to Rutherford. They were thinking that this man will do something in life. So when J.J. Thomson came to a point where he thought that he had done enough and there was no new idea coming his way, he thought maybe the next step about the atomic discovery must be from this man, and he called it. Rutherford took the material or whatever documents were there. He started to go back to his place. On the way of going back, Rutherford had already started to plan his experiment. The experiment that he was planning was going to be, according to my view, was going to be the most amazing experiment in that era. It's called as alpha scattering. In this alpha scattering experiment, Rutherford took a gold foil, extremely thin. Let this be the thin gold foil. So it's like a paper, and the paper is kept absolutely straight like this. So you only see it as a line. This is a thin gold foil, or I can draw it slightly better diagram. Yeah, this is a thin gold foil. And from the other side of the gold foil, there is an object. This is a box, lead box was created. This is the lead box. Why lead? Because the lead has the property of absorbing the other radiations. Only alpha particles will be allowed to go. And this is the radioactive sample, radioactive material. From here the alpha particles should come. And the alpha particles will hit on the given gold foil. Now this is the experiment that he did. But then, because I am not one teacher who will teach you about the experiment, I don't like that. I like to ask questions about why alpha particle. We already saw that Rutherford had discovered 3 radiations. One is alpha particle, second is beta particle, and the third is gamma radiations. Why did he choose alpha? Why not beta? Why not gamma? There are other radiations possible as well. Why only alpha particles? Why use gold foil? Why not some other foil? Gold foil is very easy to answer because gold has the unique ability of being extremely malleable. So you can take a small gold foil, put that in a textbook or in a book like this. Let's say inside this book I kept a gold foil. I closed that book and kept it right on the ground, and I took a hammer and heavy hammer and kept on hitting it. Eventually when I opened the foil has spread more. The thickness is reducing and reducing and reducing. Eventually the thickness of the gold foil can be reduced to such a minimum that maybe some alpha particle like substance or some other particle can penetrate, pass through. This is what Rutherford was thinking about. But again, this answers why gold foil, because it can be made extremely thin. But why alpha particles? Why not some other particles? And what was the logic? How did Rutherford plan this experiment? Rutherford, to make this experiment possible, you have to have a screen. And the screen is not only in front, it is everywhere because the alpha particles can be deviated. So the screen had to be kept, there has to be coating of zinc sulfide, ZNS. You have to have so many things, not just zinc sulfide, not only this, the lead box as well, the radioactive substance as well. Today it is easily available. About 120 years back, it was a big thing to have a laboratory that can sustain all this kind of experimentation. And these experiments went on for many days. It wasn't successful right at the start. So for all of this, a lot of money has to be invested. And Rutherford did not have all that money. The money would come from some rich man who would be saying, okay, you want to do experimentation? I'll give you some paycheck. You take this for your laboratory. This is my donation. But not everybody is willing to donate. So some people did donate. Rutherford took those donations. And he had set up his laboratory. But then, to use someone's money, Rutherford did not have these money lenders available every day. So whatever be the donation, Rutherford has to use them very carefully. By that I mean, Rutherford could not conduct any experiment for the sake of it because the money was limited. Whatever be the donation, it was limited. And because of that, he had to be sure that he is not wasting his resources. So he had to categorically, carefully plan it out And by that I mean alpha particles were chosen because of a certain reason, not by accident. Because there was no opportunity to experiment for the sake of it. Because the money, the resources were so limited. You have to be very accurate. At least with your thought process, you have to be very correct. And Rutherford was. So what did Rutherford think? When did he think like that? What was his logic? This is the core part of alpha scattering experiment. Let's see what Rutherford thought. So it started when J.J. Thomson had given Rutherford a go-ahead. Thomson said that he wanted Rutherford to try it out now. The discovery of electron was perfectly fine. Rutherford agreed because Rutherford also verified the experiment. Rutherford agreed that the discovery of electron is a genius discovery and there is no doubt about it. There is no question about it. But Rutherford also knew and J.J. Thomson also knew that the model of the atom that J.J. Thomson put forth, the plum pudding model, wasn't good model. But at that time it was only possible up to that level. I mean, for any further betterment of the model and tell us about what is atom really like, you have to know more about atom, and it was not known at that time. A very little thing about the atom was known. The only thing at that time what was known was atom is existing, and inside the atom there is electron negatively charged. These are the only two things which were surely known. Everything else was unknown. So Rutherford decided that he will perform some experiment to find out more about the atom. The challenge in front of Rutherford was that if inside the atom the entire thing is positively charged and the negatively charged electrons are only embedded like J.J. Thomson is claiming. If the negatively charged electrons are embedded, which means that on my hand, which might be positively charged, on one dots are there some dots, or my nails, these are all like electrons here. And if that is to be believed, then the positive charge of the entire positive charge spread across the atom and the negative charge of the electrons embedded is constantly touching each other. If they are touching each other, there is no gap between them. And if they are touching each other, then positive and negative will balance out each other, so the charges will vanish. So it is expected that they should not be touching each other because the positive and negative charges are available. You can still get it if you perform that same experiment again of J.J. Thomson's cathode ray tube. You will get electrons again. So the electrons are coming out of atom, which means that the electrons are existing inside the atom. Those electrons are not balanced by the other positive charge. But then if the positive and negative touch each other, they will completely destroy each other. The charges will be destroyed. So Rutherford decided that he will find out if there is a gap between positive charge and negative charge. Is there any gap? How do you know if there is a gap or not? How can you find out if there is a gap or not? My hand is here and my face is here. In between my hand and my face, if there is a gap or not. How do you know? The gap, you can be sure if there is a gap or not if you can see something in between. If you see, then there is a gap. Supposedly, the room is completely dark, so you cannot see anything. Then you can put your hand in between. If the hand can pass through, then there is gap. This is one table, and this is the second table. Now one table and the second table, smaller size, larger in size, whatever it is. But if there is gap between them, then some scale or a pencil can actually pass through it. The table is much larger, pencil is very small. Pencil can pass through the gap. If there is a gap between positive and negative charge, something should be able to pass through. But then what something? We are talking about subatomic particles. Subatomic particles, by that I mean the particles which are inside the atom. So these particles are smaller than the atom, and everything we have is made up of atoms. So all the objects that we know of are bigger, and this gap is extremely small. Now what do we do? How can we know if something can pass or not? Rutherford, remember that he had discovered 3 different radiations: alpha particles, beta particles, and gamma rays. Gamma rays cannot be used here because these positive and negative will have no influence on it. It will simply pass through. This is radiation, this is light energy. Not allowed, because this will not fetch the appropriate result. Positive and negative, yeah, if you have positive particle or a negative particle, you can check. You can check if the alpha particle can pass through. You can check if the beta particle can pass through. So why choose alpha? Why not beta? Because beta particle is light. Beta particle can be deflected a lot more. We have seen that in the experiment. The experiment that Rutherford performed about finding out alpha, beta and gamma particles. In that we saw that the deflection of beta particles was far greater. Alpha particles deviated less. So alpha particles were chosen because Rutherford wanted to study deviation, but he did not want to study abruptly, horribly large deviation. Beta particles were moving with far too greater of speed. Alpha particle speed was also less. So somehow Rutherford thought that alpha particle would be the better choice here. And it turned out to be an amazing choice. How? Let's see. So this is the setup, experimental setup for the alpha scattering experiment. This is the lead box, and inside the lead box a radioactive material is kept. The small tiny hole in the lead box is responsible to allow only a fine beam of alpha particles to come out. So this is the radioactive substance. Only a fine beam of alpha particles can come out and can hit here. This fine beam was hitting on the gold foil, and Rutherford was expecting to see if the gold foil is only made up of atoms. That means the gold foil is made so thin that between the 2 atoms if alpha particles can pass, there is no other layer of gold foils. I hope you understand what I am saying. No matter how thin, whatever paper we take, no matter how thin is that paper, I will show you this paper. Whatever be the paper that we take, no matter how thin, it is the thickness will have crores of atoms. But if you try to hammer it down and make the thickness as low as possible, and you make it extremely thin, maybe this thickness will be only a few atoms thick, and then maybe the alpha particles can either pass through it or their behavior can be studied. This was the attempt of Rutherford. First it failed miserably. Rutherford was also disappointed, but then he decided that maybe with some hammer he'll hammer the gold foil and will make it more thin. He kept on doing that. The gold thin was unbelievably thin after some time. One student of Rutherford was Heisenberg. This man had put in his principle, which is called as uncertainty principle. It is known as an amazing principle in quantum mechanics, quantum physics. This student, he was working with Rutherford at that time with this experiment, because some students are like, sir, if you are doing something, please call me. I want to study with you. I want to help you. Rutherford was very happy to have students come to his laboratory, study. They will study as well. They will help Rutherford so that they will learn as well. Rutherford will also get a fresh idea. Everybody is benefited. And eventually it is the science that gets the biggest benefit. And it actually happened. One night, Rutherford was going to go out to a dinner party. It wasn't a party per se, but the man who was giving funds for Rutherford's laboratory, that man had called for a dinner. And he had invited some other people, some of his friends, and Rutherford was called. I don't know, maybe he was an exhibit. Like sometimes we go and we carry with us something that we will show it to everyone, just to flaunt. So whoever was the landlord or the money lender, उसके लिए flaunting part was Rutherford saying that I am right now, meet this man, he's an amazing scientist, and I'm just funding his laboratory right now. So with that, how generous I am can be flaunted in front of my friends. Maybe that was the idea. I don't know. I'm just guessing. But then Rutherford had to go to this dinner because you cannot take someone's money and then tell I'm not coming. So Rutherford had to go. So he told Heisenberg that we cannot do the experiment today and has been failing for a long time now. For over 2 weeks, the experiment kept on failing. And Rutherford said, Heisenberg, let's call it off. We'll do it tomorrow. Heisenberg said, why sir? We did everything. The gold foil is super thin. Let's do the experiment now. Rutherford said, no, it takes a lot of time. The alpha particle can be emitted after any interval of time. One is emitted, the second is emitted after 2 hours. Sometimes 10 particles are emitted in 2 minutes. We don't know. They are completely, it's not predictable at all. And because it is not predictable, I don't know how long to wait for it. Heisenberg said, are you going somewhere, sir? Rutherford said, yes. I have to go to a dinner. That's the one who is sponsoring this entire laboratory. Heisenberg said, okay, fair enough. And then Heisenberg came up with this idea. He said, why don't you go and I'll do this experiment? Anyways, I just have to sit. Rutherford thought and he said, maybe it is possible. So Rutherford went. But then he was just getting down from his laboratory and he stopped at the stairs. And on the stairs he sat. And he sat down and he started to think that Heisenberg is capable, he is brilliant, but he is only a student. There are many chemicals in laboratory, there are many substances. Many of them are volatile. Many of them are inflammable. So leaving a student in the laboratory which can be inflammable as well, this is risky for the student. And as a teacher, as a professor, Rutherford is best advised not to do that. So Rutherford was about to turn back and go and tell Heisenberg that nothing doing, you go home, we'll do it tomorrow. But then Rutherford thought that now if he goes back and tells Heisenberg that we cannot do it, Heisenberg will think that his teacher does not trust him. So Rutherford was like, no, I trust him, I can't even tell him this. So what can be done? Eventually, Rutherford sat on the stairs and after some time he just slept there. Next morning he woke up. Thankfully it wasn't winter in Europe, it was summer, so he could sleep and he woke up in the morning, very early in the morning, and he realized that he had just slept there. So he went back to the laboratory. He found that Heisenberg had been sleeping as well on the table. He woke Heisenberg up and Heisenberg said, sir, I was waiting for you. And Rutherford said, what happened? Heisenberg said, we got it, sir. The experiment worked. And indeed the experiment worked. The alpha particle, the fine beam of alpha particle that was incident on the gold foil, the gold foil was made so thin that assumably, only an assumption, only one atom thickness was maintained or a few atoms thickness. As a result of that, if one beam is hitting this atom, then no other atom is in the way. So all other atoms are irrelevant. Rutherford wanted to achieve that, that's why he was making the gold foil so thin, and it had reached that thin layer. Now after that, some alpha particles were found. It was found that most alpha particles, by most I mean 98% of alpha particles went without any deflection. They went absolutely straight. It is as if you did not place the gold foil, and where would they hit? They will hit here, let's say. They will produce a glow here on zinc sulfide. Even with the gold foil, 98% of alpha particles produce the glow at the same spot. So they went without any deflection. Out of the 2%, majority, not the entire majority, ye 98% is done. Out of the 2% left, majority of these were deflected through very small angles, like 5 degree, 10 degree, 9 degree, 11 degree, extremely small angles. Very few alpha particles were deviated through 90 degrees, 30 degrees, 60 degrees. Very few, literally very few. And only one out of 10,000, only one alpha particle. If the 10,000 alpha particles were emitted, only one alpha particle returned back. Experiment had been successful. The observations were recorded. Rutherford sat down with his paper and pencil to make some sense out of this. What is the sense behind this? Why are alpha particles deviated? Why did 98% of alpha particles went without any deflection? Out of the 2%, why majority suffered minimum deflection? Why only extremely few alpha particles suffered large deflection? And why only one alpha particle went back the same path? It's like going there and absolutely returning back. Why? Rutherford wanted, and he had to make the sense out of all these observations. He had to sit down, he had to put his mind over it, try to figure out what is actually happening. And Rutherford actually figured out. So what did Rutherford figure out? What was the conclusion of these observations? Let's see. Rutherford said that the gold foil is so thin now that we can consider that the entire alpha particles were incident on only one atom. There is no atom after, before, in between, in that line. So only one atom is being bombarded with the alpha particles. And out of these alpha particles, 98% went straight without any deflection. So Rutherford said that a 98% space in an atom is empty. Because 98% of the space is empty, that's why 98% of alpha particles go straight without any deflection. Because 98% of alpha particles went through those regions where there is no one to stop them and no one to deflect them. So the alpha particles could go absolutely straight. That means that 98% of the space is empty. Next observation, Rutherford said that because some alpha particles are deflected, most are deflected through very small angle, some are deflected through large angles. Rutherford said small angles, large angles, we'll talk about that later. But the alpha particles are deflected because of two reasons. One, there is a negative charge here. This is possible reason. One is negative charge here. Alpha particle is positively charged. So this is positive and this is negative. And the positive is attracted because of the negative. The speed is so large that it doesn't stop. But the attraction will change the direction. And that is why the angle is there. The deflection is there. Second possibility is this is not negative, this is positive as well, and a positive alpha particle is coming. This is positive, this is positive. The repulsion is there. The speed of the alpha particle is so large that it will go ahead. It will not stop. But the deflection will surely be there and will go in this direction. So the direction can change because of two factors. One, the attraction of a negative object. Second, the repulsion of a positive object. Rutherford said both are possible, and there is no reason for me to conclude that the pulling object or repelling object is either negatively charged or is it positively charged. There is no reason for me, there is no logic with which I can tell one thing or the other. But there is one observation which is giveaway, which is like it will tell you the entire story. This alpha particle is coming back. If this particle here, whatever be the particle, was negatively charged, this alpha particle, positively charged alpha particle, will never come back, will be attracted. This alpha particle comes back, this can only happen because there is a positive particle here and the alpha particle is going for an absolute head-on collision. And the repulsion between them is so strong that it stops. The alpha particle stops here and because of the repulsion it goes back. Rutherford figured out that this is positive charge. Because of this positive charge, some alpha particles are deflected through smaller angles. How? It is very easy to predict now. This is positive charge. The alpha particle is also coming with positive charge. So positive repulsion. This alpha particle is deflected. Some other alpha particle came very close, so it is deflected through greater angle. Some alpha particle went extremely close, it is deflected through far greater angle. Some alpha particle went for a head-on collision. The repulsion got the alpha particle to stop and go back. So the alpha particle went back its original path. So this is the positive charge right at the center of this, whatever we call it, this is an atom. So right at the center there is this positive charge where everything is being bombarded. So Rutherford put forth two important conclusions. First, 98% of the space inside the atom is completely empty. Second, right at the center of the atom there is the positive charge. The positive charge is the entire positive charge of that atom is stored inside those central 2%. The rest 98% does not have any positive charge. Otherwise this 98% would never have gone straight. They would have been deflected as well. They are not deflected. That means that the entire positive charge is right at the center. 98% space is empty. The remaining small space at the center has the entire positive charge, and this is where the entire mass of the atom is also stored. This is called as nucleus. Rutherford called it nucleus. Human body cell was already discovered long time back, and the central part of the cell was called as nucleus. From that terminology, atom's central part is also called as nucleus. Rutherford used that name. So the atom's center, which is positively charged, is called as nucleus. It carries entire positive charge of the atom. It also carries the entire mass of that atom. This was put forth by Rutherford. Now, what about the neutrality of the atom? Because if the atom is only positively charged, then everything we touch must also be positively charged. So whatever we touch must give us an electric shock. But it does not happen. So everything is not positively charged. If everything is made up of atom, but it is not positively charged, that means the atom is not either positively charged or the positive charge is balanced by the negative charge. Rutherford said this is the central atom. Rutherford said that This is the nucleus inside the atom, and this is the entire atom. The nucleus is at the center, and then Rutherford said that there are electrons around the atom's nucleus. These electrons are continuously rotating around the nucleus, like planets rotate around the sun. The sun is continuously pulling the earth and other planets as well. But that pull is utilized for the rotation. I hope you understand this. If I am rotating something, I am basically pulling that object close. Why? Because the change of direction can only happen without that, because of this pull. The force of attraction is used to change the direction. Otherwise, how can something which is rotating change the direction? And we are not talking about somebody holding a rope and rotating. The earth is not holding any rope. The earth is rotating around the sun. The earth can go in the same straight line and will never come back to the sun. It does not happen because the earth is feeling the pull of the sun and the direction is changed all the time when the rotation happens. Rutherford said that like the planets revolve around the sun, despite of the attraction between them, the distance between them is maintained. The gap is maintained. The attraction does not decrease the distance between them. The moon is attracted towards the earth, and the earth is of course attracted towards the moon because gravity works like that. So if the moon is feeling attracted towards the earth, still moon and earth's gap does not reduce. They don't come close to each other. Moon maintains the same distance and rotates around earth. The attraction is used for rotation, the change of direction all the time. Similarly, the electrons are feeling attracted towards the nucleus. This attraction is causing the change of direction so that the electron can rotate. And because of that rotation, the electron will maintain their state of rotation around that object all the time. So this is a circular motion which will go on for infinitely. It has been going on for infinite years and it will go on for infinite years, and the distance between positive and negative will remain uniform. So the positive charge and negative charge are not coming close to each other, so they are not touching each other, and if they are not touching each other, the charges will not cancel each other. So the most important limitation of J.J. Thomson's atomic model was completely overcome by Rutherford. And this model was not put up by a simple fancy idea. He had done hardcore research about it. That is why I tell my students that Rutherford was a genius. Very seldom in my life have I seen such a genius at work. So let us summarize the great work done by Rutherford. He started with a model which was based on a genius experiment. The genius experiment of finding out the electron, the cathode ray tube experiment, was an absolute genius. The discovery of electron was brilliant discovery. The inference drawn that it is not just the electron but the atoms must be existing and the electron must be a part of the atom. This was absolutely brilliant as well. But unfortunately, this led to the model of the atom, and J.J. Thomson tried to tell according to him, what does an atom actually look like. This was pretty ordinary because here the entire mass was positively charged and the negative electrons were only embedded in it. The positive negative touching each other is really, no, it's not possible. This started the thought process of Rutherford. He came up with an experiment of alpha scattering. The alpha particles were bombarded on the gold foil, and the path or the deflection of the alpha particles was studied. And then he concluded that the entire atom, only a little bit of atom is filled. The central portion of the atom, extremely tiny portion of the atom, is actually containing all the mass and all the positive charge. The rest of the atom is completely empty. Later he said that extremely small in size, tiny negatively charged electrons are around the nucleus. This is nucleus inside the atom, and they are revolving around the nucleus, just like the planets would revolve around the sun. Like the planets will orbit the sun, the electrons are revolving in circular orbits around the nucleus. So he called these electrons as planetary electrons. These planetary electrons revolve around the nucleus in the circular orbit. As the circular motion goes on, every electron maintains its distance, the radius, from the nucleus, which is the center of the rotation. So the radius is maintained, the distance of separation between the nucleus and the electron is maintained, and despite of the attraction between them, the electron never falls on the nucleus. As a result of this, the enormous attraction between the positively charged nucleus and the negatively charged electron still cannot decrease the distance between them, and the two opposite charges never meet each other. So the entire contradiction in J.J. Thomson's atomic model has been completely nullified in this. Although Rutherford's atomic model also has a few issues, few limitations. What are those limitations? We'll talk in the next video. But overall, if you see, Rutherford had come up with an absolute genius experiment, and the reasoning of that experiment, of those observations, led to a spectacularly atomic model. Like, because the gold foil or any cathode that you take, like J.J. Thomson was working with cathode, and then the cathode ray tube experiment, and then actually the electrons were discovered. And he was holding the cathode, they were all metallic cathodes. So he thought that they are all solid. So in this atom, the model of atom, J.J. Thomson's, in that model of atom, the entire atom is filled with positive charge. There is no empty space there. Electrons are embedded, but it is all filled. Thomson's limitation, while overcoming, Rutherford came up with a revolutionary thought. And he said that the entire atom is almost empty. 98% of atom is empty. Now, how amazingly appropriate is that? You see, our solar system, huge, there is sun here, and there are planets revolving. But all these rings, they don't matter, because at one point a planet will be here, some other planet will be here, some other planet will be here, some other planet will be here. A Jupiter will be bigger, Saturn will be bigger. But if you take the entire solar system, it is completely empty. Only some part is filled. Only some part has solid substances of mass there. Rest is completely empty space, vacuum. Same is happening here. Now we know that science has matured enough, the discoveries have matured enough that we can understand that what is there in the enormously large world, the same thing actually exists in an extremely tiny world as well. The kind of structures we see in solar system, same kind we can see in an atom. The center is the nucleus, the center is the sun here in the solar system. The planets revolve around the sun, electrons revolve around the nucleus. Most of this space is empty. Most of the atom space is empty. This world would not have extreme similarities despite of completely different size. This is enormous in size. This is extremely small in size, but they completely resemble with each other. This only happens because if both are created by the same principle. The science actually aspires to know about this as well, but that discussion in some other video. I hope you like this. I hope you agree with what my insights are. I hope you also appreciate the genius work of our Mr. Rutherford. Thank you so much.